All right, we can kick this off. So, greetings everyone. Thanks so much for joining us from all around the world. Today we're bringing you a live virtual workshop with the amazing team from Cronos Labs and Tenderly. We're here to do a deep dive into the Cronos Tenderly integration and what this means for developers. And we'll also show you several ways to speed up Dapp development on Cronos with Tenderly. We've got a power duo joining us today. Ella Chang, the head of ecosystem and partnerships from Cronos Labs, joining us from Singapore, and Nenad Vitorovic Devrel at Tenderly, joining us from our HQ in Belgrade. Welcome to both of you. But before we kick this off, I want to invite everyone to stick around till the end, because we'll host a live Q&A session with Ella and Nenad. So be sure to drop your questions during the presentation, any questions you might have in the Q&A box here on Zoom. So let's get this started. Ella, can you kick us off by giving an overview of the Cronos ecosystem programs and tell us a little bit about the impact of your vision and its impact on developers in general?
Yeah, for sure. Well, hello everyone. Thanks for joining today's event, and I'm super excited about this collaboration with Tenderly, and obviously this is just the beginning. I'm very excited to introduce Cronos and our ecosystem programs to the developers in the EVM ecosystem and Tenderly ecosystem. So my name is Ella. I lead ecosystem and partnerships at Cronos Labs. So for those who are not super familiar with what Cronos is, we're the first EVM compatible chain that's built on the Cosmos SDK. And the chain is mainly powering DeFi and Web3 gaming use cases that's targeting retail users. So a few key points about Cronos. It's an open source project maintained by crypto.org. It's EVM compatible, so it means that if you have already built on other EVM compatible chains, it's very easy to port over to Cronos. But at the same time, because we're built with Cosmos SDK, it enjoys the modules that comes with the Cosmos SDK, such as IDC Bridge, which allows interoperability with other Cosmos app chains. So we launched mainnet beta in November 2021. So it's been a bit over a year, and right after the mainnet launch, the chain, especially the DeFi ecosystem, has been growing very rapidly, and we have been remain in the top 10 chains. I think only a few months after we launched, and right now we're still number 9 among all the chains. And Cronos Chain is very fast, it's cheap, and also carbon neutral. Transaction fees are paid in Cronos, the CRO token, which is also a top 30 cryptocurrency that has been widely held by retail users, given its history with crypto.com. So for builders, devs, why do you want to build and grow on Cronos Chain? So first, I think we're pretty unique in the sense that we're sitting in between the Ethereum ecosystem and the Cosmos ecosystem. And I think with this direction that we're moving forward with multi-chain world, this makes us very unique as more and more like cross-chain DeFi or gaming use cases are being explored. And the most, I think, unique property about Cronos is we're not really a new community. It has been a very strong and engaging retail-focused community from years ago, from the days of Monaco and crypto.com started. So we call our community, or the community has named themselves Crow Fam, and there are about 70 million Crow Fam all around the world, and they just entered the crypto world and very eager to learn and very eager to enter the Web3 world. And we think that Cronos is uniquely positioned to tap into these new users and onboarding them to the world of self-custody. And those retail users usually have a very large appetite gaming, for esports, for DeFi, which makes a lot of the Dapp Web3 dApps that are expanding to Cronos Chain found that they were able to achieve very high traction on Cronos versus some of the other chains. And then because of the support from Crypto.com, Cronos also enjoy on-ramp and off-ramp for certain fiat currencies, as well as some of the large top 50 tokens via the Crypto.com on-ramp. And last but not the least, we also have a lot of support from Crypto.com. The whole suite product and services, exchange, NFT, marketplace, their non-custodial wallet, etc. And then later on, I will also talk about some of the programs from Cronos Labs that are set up to support with projects from different stages. So right now, there are about over 500 dApps as well as infrastructure partners on Cronos. So this is just two main verticals that we're quite focused on. So on the DeFi front, right now there are about 400 million total value locked, one of the top 10 chains. And then about 90 DeFi protocols that are live on Cronos mainnet, and 13 out of them are above 1 million TVL. So this is some of the top DeFi protocols listed there, but this is just a snapshot of a few selections. And then Web3 gaming is also a key focus for us, because we believe that gaming is a very good entry point for new users coming to Web3, as not everyone would be, expert in finance or very interested or sticky to finance products, but most people enjoy playing games. So we believe that by introducing self-ownership as well as adding the earning component, gaming can provide a tremendous opportunity to onboard those users into the world of Web3. So a lot of new development in the Cronos ecosystem on that front, especially the past half a year. So right now, about 20 games that are already live on Cronos, and 15 plus more that are in the building phase, and we will see them launch in Q1 and Q2 this year. So super exciting. All right, so one of the ecosystem programs that we are running right now is the Cronos Accelerator program. So what we believe is we not only want to support developers and builders to build in the ecosystem through the regular channels such as ecosystem grants, but at the same time, we also want to spot early stage founders, early stage projects that have very interesting idea, innovative models, and we want to support them from early on. So Accelerator program is really set up with that goal. So this is a 3-month long program that aims to pick and accelerate the best teams in the Cronos ecosystem. It's 12 weeks long, and we're looking at 6 to 8 teams per cohort. So it's highly selective. In the last cohort last year, the acceptance rate is about 3%. And then there's an investment component goes into that as well. So every team admitted into the accelerator program will get a 30,000 stipend. And then there will be up to 300,000 follow-on investment based on milestones. And then by the end of the 12 weeks, there will be a demo day where other projects will present to a wide, large groups of investors, DAOs, and angels that we partner with. And then during these 12 weeks, we arrange different one-on-one mentorships. Every single week, there are different curriculum, especially on tokenomics, on fundraising strategy, on community marketing. And from the feedbacks that we obtained from the first cohort, especially for projects that that are first-time builders in Web3, or they're entering from Web2 to Web3 space, they found those especially valuable. And then we also have like marketing and integration support from both Cronos Labs as well as Crypto.com. And we also negotiated a wide range of infrastructure package or perks from various partners, such as credit discounts for the API calls or RPC service, legal service, etc. So these will be all exclusive to projects that are admitted to the accelerator program. So if you're interested, I highly recommend you to take a look at the accelerator program and then apply. So right now, applications are open, and then the deadline to apply for cohort 2 is March the 24th. And then the program will kick off in late April and run all the way till early July. So if you want to find out more, go to Cronos.org in accelerators. And we're also running office hours. So if you have any questions, go to the Cronos Twitter handle, and then the first post you see will be book a 15 minutes office hour slot with us, and we'll tell you more about the structure of the program. All right, that's it from my side.
Amazing, amazing. Thank you so much, Ella, for this very, very insightful overview of the Cronos ecosystem and the benefits of building on Cronos, actually. So hope all of you builders joining us today, hope this brings you a little bit closer to exploring Cronos features and benefits if you're not building on Cronos already. Now I want to hand the reins over to Nenad to show us the Cronos Tenderly integration in action and demonstrate all of them, or just a couple of amazing things that you can do with Tenderly to speed up your Dapp development process on Cronos. So Nenad, take it away.
Thank you, Danilo. And thank you, Ella, for that overview of what you guys do at Cronos. Sounds very exciting. And I'm very excited that Tenderly tools will now be available for Cronos developers. So my goal today here is to give you an overview of Tenderly developer platform. What is it that it can do and how it can support developers in their work and make it more efficient. Then we're going to jump straight into a demo about debugging and testing smart contracts using Tenderly's debugger and testing support. And next, we're going to talk about how you can use Tenderly actually as a UI builder. So when you're building your Dapp's UI, how can Tenderly tools actually help you be more efficient there as well? And the last part is simulations in Dapps. So this is more about understanding the needs for better user experience in Dapps and trying to address them with simulations. So I have 4 things to go over. I hope I can make it in a reasonable amount of time. And let's segue into the platform itself. So Tenderly is an all-in-one platform that gives you tools that support the very development of smart contracts with the tools like Gas Profiler and Debugger, so you can optimize and, well, of course, fix bugs in your smart contracts before they actually cause any harm. Then we have Transaction Simulator and Forks. So the Transaction Simulator allows you to basically run transactions on your smart contracts from an IDE-like experience. And forks are, well, practically a simulated network period. And we'll get back to these in the demo. So I'll switch over to the next segment, and that's observability. So when your product is live on a network, you do want to sort of understand how it's used. So there's analytics, there's mission control, so you can understand what's happening on your project. There's also alerting that allows you to, well, receive notifications whenever something really important happens on your smart contracts, either a specific value is being transferred, or a particular function is called, or an undesirable address called your smart contract, and then you get a notification to your Slack or a Discord or whatever. And the last but not least is the infrastructure building blocks of Tenderly, and We, of course, have support for, now this number is outdated, 23, now it's a little more networks. We offer several APIs, among which the simulation API is the one that can help you bring most value to your end users, and we'll touch upon that one in the demo as well. And there is another component called Web3 Actions, which allows you to have a little piece of code that executes whenever something important happens. Again, a token has been transferred or a particular value is being transferred. So you can run a little bit of your JavaScript whenever something big or important happens, so you can automate your reactions to whatever is happening on the chain. So this is Tenderly in, I hope, less than 2 minutes. So we're an all-in-one developer platform helping you to not only develop and improve your smart contracts, but also when it's in production to automate things around them, have good alerting mechanisms, and improve the overall experience of the for the end users of the Dapp, but also improve the overall developer experience along the way. And that's it for the brief overview. And now that we mentioned that Tenderly is helping with development and debugging of smart contracts, let's see how that looks like. So here we're seeing a transaction that's failing, and this is the Tenderly dashboard. You can, of course, subscribe to contracts you're interested in and see the transactions that's happening to them. And I picked one that failed. And here it says that the error message is insufficient confirmations. So the way to debug it would be to actually use the Tenderly debugger. I'm going to make a little segue, and before actually jumping in the code, I'll just introduce the smart contract that's in here, and that's a very rudimentary multi-sig wallet. So with multi-sig wallet, you can submit a transaction into it that's been sent to a particular address with particular value and particular call data. So the input of transaction, and then several people must agree or confirm that yes, we want to execute this transaction. So we need to have a group agreement that the funds from the multisig can actually be used for this purpose. And when we have enough of confirmations, then one of the owners of the multisig can execute this transaction. So this event over here is emitted. And you can see here, of course, that there's the owners array. There's the number of confirmations required. So that's how many of these people, owners, addresses, have to confirm that transaction is something that we wish to see executing on chain. And if you scroll down, you can actually see the methods. There's submit transaction, confirm transaction, execute transaction, and so on. So this is the contract we're dealing with, and this is the contract that failed. Now, to debug it, we can see here that it says the execution is reverted. It says on which line, and you can see, you can actually see the calls and jumps that have happened to this smart contract. And if I click debug error here, it'll take me exactly to the place where the transaction reverted. So this is this required statement. I'm going to zoom in just a little and move this aside. So what we can see here is that this require failed, apparently. So we have to figure out why it failed. It's a very simple bug. I guess some of you may notice what's the issue here, but let's go through the entire debugging process. So, of course, this one is false. I'm going to copy the entire expression and open up the evaluate button over here, the evaluate window. So I can paste any solidity expression that is meaningful in the context of this contract and hit evaluate, and I will get the result. So yes, this appears to be false. Now let's see individually how many confirmations did this particular transaction get. So to do that, I'll just remove the right part, click evaluate, and here it says it's got 2 confirmations. And here, let's see how many of those are required. Well, it says 2. I guess the error is pretty obvious. Here we should have had greater than or equal to. We need at least this number of confirmations. So if I add an equal to operator, click evaluate, this will result to true. And this is probably the bug fix of our logical bug over here. So unfortunately, we cannot edit this code over here, but to verify that this is the bug and adding an equal sign is the fix, what we can do is either redeploy the contract and go through the process again, or we can use the resimulate feature over here. So if I click this button, it will take this transaction and put it into the transaction simulator. This is the second piece that we mentioned. And what we could do here is, well, we don't want to change the input data, but we do want to see what happens if this transaction runs on a modified source, which includes the bug fix. So I'm going to click the edit source code button, here, contract source button over here, and I'm going to go to the exact line that failed, and that was in the execute transaction function that's over here. And here you can see that we have our problematic little piece of code. I'll just add an equal sign over there, and I will hit apply changes. So now when we simulate this transaction, it will run against the bug fixed code, and we'll see if this is a bug fix or not. Before doing the simulation, I'll just briefly go over the simulator. So you can actually specify any sender address, any gas value, any gas price. You can even move this transaction to a different block. You can pass it a different timestamp and so on. You can even do state overrides, meaning you can put arbitrary values into the state variables of the contract. And of course, you can add an access list, but I'm not going to do any of that. I'll just simulate the transaction. And here we can see that, yes, it succeeded. The execute transaction was invoked properly, and it went through without a revert. This means that the tiny little adjustment to the code actually fixes the bug, so we can apply it in our code base. Now, before applying it to the code base, let's just take a moment to look around what's there, what's in here when you look at a executed transaction. So yes, you can go here and you can see all the contracts involved in the transaction. You can go to events and you can see the decoded logs, decoded events. This is the raw variant of it, really not legible. But when you go here, you get a more user-friendly, person-friendly, people-friendly display of the events, which can help you understand how transactions execute, what they do, and so on. The following tab is the state tab. So this actually will show you the state changes that happened transaction executed. So here we can see that this executed flag got set to true. And of course, you can also see the changes in the balances, the nonce, and so on. And of course, if there are multiple different contracts involved, you can see all the changes in those contracts. And last but not least, there's the gas profiler, which can actually show you how each function in the call chain use the gas. Now, this is a pretty simple one. If you open up a more complex one, you could see a deeper flame chart, and you can also use these different navigation options to jump into debugger, into the very function, examine the source code, figure out if it's too much gas and where the gas is could be optimized. All right, so this is the transaction overview done very briefly. Now, what we didn't discuss is that this is a, it says here that this transaction we've seen from the very start, this is the one that's failing, is a simulated transaction. Keep that thought, but let's first finish what we actually started, and that's fixing the bug. So we'll head to Visual Studio Code, and I'll find the execute transaction. Oh, it's not here. And the solidity here. So I'm going to scroll down to execute transaction. Here's a little bit. And I'm going to change this to greater than or equal to, just like we discussed. So this should fix the bug. But the fun thing is that actually the output you've seen and the transactions you've seen actually comes from a hard hat test. And here's the test. We're not going to go into that. And well, you can configure hard hat to actually run those tests against the simulated networks we spoke about. So when I click, when I send this to my terminal, of course, it goes around, deploys the contracts, and so on and so on. But where is actually all of this being deployed, and where is it executed at? It's on your left-hand side, it's a fork. So while the tests are running, forks are simulated networks, and that means you can pick practically any network, mainnet, you can pick Cronos, name it, you can actually slide it back in time, so you can pick any arbitrary point in time where you can where you want to fork the network, click create, and this is all the time it takes before you actually get a usable simulated network. And those networks actually forks expose a JSON RPC URL you can copy and place anywhere you expect an actual network. And in our case, I'll show you the hard hat config. So the network I was running the test against was called Tenderly. And as the URL, it had this thing that's Tenderly fork URL that I'm pulling in from the environment variables. And if we look at that, this is the RPC of the first fork that we were on. So this is a way to use forks as an infrastructure for running your automated tests. And the benefit of doing that is that, this is the one, the benefit of doing that is that you have all of these transactions recorded, you can debug them, you can run them again, and so on and so on. And basically it gives you infrastructure for very speedy integration tests. All right, so that was the first part. And the second part, this is debugging and testing smart contracts. The second part would be using Tenderly infrastructure to when you're building a UI. And you may guess it, the same way we used the fork to run automated tests, we can actually use a fork as a environment for building UI. Now, I'm running a little script here that is actually using the fork API to create a new fork and to deploy the multi-sig contract that we've just seen. And let me just refresh this. This is the UI fork now. This is the one that we got. And we have two contracts deployed, multi-sig and tic-tac-toe. So you can imagine creating a very quick environment builder for somebody building a UI. And to that regard, let's open this beautiful UI I made. So let's just do one little check. We have our multi-sig wallet. It says here that it's on address to AO0, AOBDB, and so on and so on. That's right. The tic-tac-toe contract is on 619, and this is the one. We'll speak about this one briefly. And let's explore how you can actually, when building UI, what's the benefit of this? So, of course, you're building your UI, you're interacting with the blockchain, and you want to quickly try out the UI that you built and see if it behaves as expected. So in order to do that, let me go back here and let me just quickly go to this line. So this is the UI that I built in Svelte because it's super easy to demonstrate. So what we have here is actually creating an ethers provider, a JSON RPC provider, initializing it with the forks RPC URL. So this is again coming from the environment variable. And let's say that we want to just submit a transaction to the multi-sig wallet. So what we're doing here is we're basically building a contract object, calling the submit transaction, giving the transaction parameters, and using ethers as we usually would. So the only difference is when we set things up, we connected the fork as the provider. So that means when I click this submit to multisig, just a moment here, and I'll reload the view. We should have as our top transaction, submit transaction. So this is the one that we just did. It's first one in the multisig, so it's got the index 0. And if we go to events, we can see that it is 0 with this call data, which maps with this thing over here. So now you've actually very quickly verified that, yes, you built this part correctly. Now, we can play around with the multisig a little more. We can say confirm by assigner 1, just wait a bit, and it looks confirmed, and then confirm by assigner 2, and it looks confirmed. And when I reload the window here in the fork, it says, yeah, we had 2 confirmations, very good. And then I hit execute. So now, I guess I didn't put a loader in there, but it should be done by now. Oops. Yeah, execute transaction. Oh, and this one failed for some reason. Now let's go in and check it out. All right, so this is a failure coming from the very contract that's being called. Let me take this one out for a second. Make some space. So here it says that in the tic-tac-toe contract, so that's the transaction that we actually packed in the multisig, this one failed. And if I go to the debugger, well, it shows me the source code of the invoked contract and this very condition where it failed. Now, this is not a bug, this is a proper behavior, because what I intentionally did here, I was trying to join the game which was not yet created. So if we want to create a new game before we can join it, then we have to call the new game function. And let's do that. So let's create the new game. I'm going to go back into this fork, and I'm going to say, I'm going to do a new simulation on the tic-tac-toe contract. So this is the one, and I'm going to make a new game over here and leave all of these fields as is. Simulate transaction. And now that we did this, we can see that we have the game ID with the game ID 1 created, and it exists. So if we execute this multisig transaction again, it should pass, it should work. The important thing here is that even though we simulate a transaction on fork, it goes into the fork's history like you sent it to an actual network. So this is the latest one that our new game was created. And I'm going to hit execute here, wait for a little while, reload, and I'm really hoping this time it's working. Yeah, execute transaction is there. And we can see that it's called the join game. And if we go into the events, we have not only execute transaction coming from the multisig, but we also have the event player join game coming from the tic-tac-toe contract. And those are the ways that you can actually use to speed up your UI development. Another interesting thing that you can do when you actually run all these simulations, for example, if you want to get the call data for the new game function, and this is the one that we've simulated within the fork, well, you can actually just copy it here, paste it over there. And now if you submit this to multisig, it will execute, it will be added over there. All right. And for the last part, we have the simulations in Dapps. Recently, we gave a webinar on this topic, and basically the idea is that by using simulations, you can actually show your users what are they are about to sign before they actually sign it. So you can show them, for example, the tokens transferred, the balances as they change, as the transaction executes, and so on and so on. And we're going to do this by using the simulation API. Now let me go back here, and simulation API works in a very simple way. You have to take your transaction and put it into an object. So all of these fields from toValue data are actually transaction fields. And additional property is that you need to add a network ID. So this object represents the transaction you want to simulate before your user sends it to chain. Now, how do we do the simulation? Well, it's a simple REST interface that allows you to do this. So the simulation URL, of course, has your user, project, and of course the simulate endpoint. And the only thing we do is we send it the parameters, the transaction we want to simulate. And as a response, you can either get the simulation error message, or you can get a whole lot of information about how the simulation went. And we'll see that in a moment. And you can also point your users to actually see that simulation in the Tenderly dashboard. So we'll get to see all of that in a moment. To go back here, since simulations are working with contracts that are deployed to an actual testnet or mainnet, I'll switch from these and switch over to some contracts that I already deployed to a network, to the Cronos testnet. And this is the new address of the multisig. This is the new address of the tic-tac-toe. So again, we're trying to join the game one. And as you've seen in the previous segment, this should fail. And if I click simulate, it says it gave us a nice little message, no such game exists, and it gave us an option to view the simulation. So I'll just quickly go here into the console because I simulated this and logged it out. So you can actually see that the simulation API gives you as response, of course, the addresses that are involved, the call trace. So that's all the functions that have been invoked when the transaction executed, the error info. So that's the error message coming from Solidity. And you have a lot of different information here that you can actually use to show something even more sensible to the users, as in recommendation, yes, this is a transaction with desirable effects or undesirable effects. And of course, let's open it up. So when you simulate a transaction, you get the very same view as the one that we saw in the testing part. So you can actually see when it failed, why it failed. You can go into debugger, oops, invalid opcode. So this is an error page. I'm going to reload it. So you actually get all the information that you would for any regular transaction. So this is how simulations can actually help your users see if they're doing something that's either going to cost them gas for reverted transactions or make it have undesirable effects, so they actually unintendedly lose some money. And I think that's about it that I wanted to demonstrate today. So the demo part is over, and let's get over to the Q&A section.
All right, thank you, Nana. Really, really nice, brilliant demo, and a lot of helpful information there. Just a note for everyone from the audience, if you want to explore any of these features a little bit more and discover other ways to use Tenderly to simplify your Dapp development, a great place to start is our documentation. You can check it out at docs.tenderly.co to learn more. Now we have a couple of minutes, so we don't go over time. We have a couple of minutes for some questions. We have several questions. Nana, there are two questions that actually related to the code that you showed. Two people from our audience are asking if you can share the code to the GitHub repo to them. I'm not sure if it's private or public.
Of course, yeah, the repo is not public yet. It's in the works, but I'll actually push it to GitHub and make it public, and we'll find a way to share the link after the demo.
Fantastic. Thanks so much. I have one of the questions was for Ella. So what types of projects the Cronos Accelerator program is currently looking for? Can you give us a little bit more context there?
Yeah, for sure. So each cohort we would have slightly different themes, but mostly we're looking for projects in three verticals: advanced DeFi, Web3 gaming infrastructure, and then tooling and infrastructure in general. So under DeFi, we're interested in projects that are, building more capital efficient, lower risk, new model of DEXs, new types of lending protocols. Fixed interest is quite interesting. Under collateralized loan is interesting. Derivatives, as well as the cross-chain DeFi use cases. And then on the gaming front, we're mostly focusing on the tooling and infrastructure side. Different gaming infra that allows Web2 game developers to easily build Web3 components to their game. And then on the infrastructure side, we're interested in ZK-proof use cases and technologies. We're interested in decentralized identity that can be like a plug and play layer to various Web3 applications. And then we're also interested in infrastructure that allows like better, smoother new user onboarding experience. So things such as social logging, account abstractions, and ways to improve on-chain securities. So these are kind of the types of projects we're looking to for cohort 2.
All right, thanks so much. Thanks so much, Ella. And we have a couple of questions here related to forks. So I find one of the questions is, I find interesting this concept of forks. It means we can deploy several versions of one smart contract that could be accessed by anyone. Is that a right assumption?
Well, I mean, you can deploy several versions of one contract on several forks. So if they have access to the fork, yes, they can access it. So that's completely doable. Of course, the fork is a simulated network, so in that sense, it's not as reliable as an actual network. It's just for development purposes and testing purposes. But yes, the answer is one smart contract, several versions, completely doable.
All right, thank you. And one more question related to forks. So how do you simulate the fork networks? And are there any plans to expose the API service for transaction simulations?
So how do we simulate a fork network? So basically, we don't actually make a fork as in copying the data and so on, because we whenever we integrate a fork with Tenderly, like we're doing with Cronos, we sort of have a very fast way to read the data that's on that blockchain. So whenever you actually send a transaction to the fork, what we do is we use a state of the fork in a particular point, and with that in mind, whenever you send a transaction, then we just execute what would happen and give the result back. So this is the way that we simulate the fork networks, and this is practically how you can get a very speedy access to a simulated networks. The fork is accessible, as I said, through JSON RPC, and this is the way you can use it to communicate to the fork, and also there's a fork API available.
All right, thank you, Nenad. And all of this is available on our documentation. So docs.tenderly.co, you can find more information there about forks, the API, and all that good stuff. And one more question for Ella to wrap this up. So can you give us what are some possible use cases for simulations? And if you can give us more context there and some examples that come to mind.
I think that's probably more of a question for you guys. That's also what I'm interested in learning.
Sure, yeah, you can both chime in. Nana, do you have any potential use cases for simulations?
So as we spoke in the demo part, you can use the basic of simulation is that you get how a transaction would execute on a chain without it actually reaching the chain, without changing anything or touching any smart contract. So the use cases for simulations would be, of course, improving the Dapp user experience by showing additional data to the users. But also if you have some sort of automations that could have, let's say, benefit of getting information, what happens if I execute the following transaction, and sort of steer the logic of your code, this is where simulations can be very useful. So it's actually getting the understanding what would happen if I do this, and either your end user or your code can decide this goes further or not. So you could practically run simulations of complex swap scenarios. You can take not only one, but a bunch of transactions and stack them up and see if let's say, a strategy is optimal or not. So those are the use cases, and practically high level, whenever you need to make an informed decision about something, simulations can actually bring more visibility into what you're about to do before you actually do it.
I remember seeing during the hackathon some developers use Tenderly simulator to build some like anti-fraud or like malicious activity layer, to protect the user. So that was pretty cool.
Yeah, I mean, you can practically show use the events that get with the simulations to show the tokens that's been transferred. You can list the contracts that are executed. You can within the transaction. So you can add many different security checks to actually see if your transaction is what you expected and think of it to be, or something different.
All right, fantastic. Thank you, Ella and Nana, so much for this very, very interactive Q&A session. Unfortunately, we don't have any more time. We actually went 5 minutes over, but I wanted to let everyone to get answers to their questions. We have several more questions unanswered. So if we didn't get a chance to answer your question live, if you didn't post it anonymously, we will email you the answer right after this event. But if you have more specific questions about Tenderly, its features, different tools that you can use, you can always get in touch with our support at support@tenderly.co on Discord, or you can also message us on Twitter. Ella, thank you so much for being with us today, or this evening for you, actually. I know it's pretty late in Singapore, so really appreciate your time here today with us. Nana, I also wanted to thank you for preparing a brilliant presentation and providing all these answers to these great questions from the audience. Just a reminder that we'll email this recording to everyone who signed up for the workshop, so watch out for the video in your inbox. And also don't forget to follow us on Twitter and Discord, and keep an eye out on our website to stay up to date with the latest from Tenderly. Thank you guys again, and see you soon. Bye, everyone.
Thank you so much. Bye.